our daily life we see the many things to happen. Sometimes we ignore them, but sometimes it clicks our mind that how it is working. What is the principle behind that? If you are one of them, then don't worry, because you are on Civil Beats. Here you will get detailed description about the principle working behind them. So without wasting much more time, let's begin the today's topic, which is known as prestressed concrete. Firstly, let's understand the concept behind the name of prestressed concrete. As the meaning of prestress is that it is already in stress. When any type of load is applied on any material, then different types of stresses are produced depending upon the nature of the load. Produced stress may be tensile stress, compressive stress, shear stress, bearing stress. Suppose if we are applying a load on any structure which will produce a stress in that material, what if an opposite stress is already present, which will counteract the stress produced by the load? Due to this already present stress, structure will work very effectively, and can bear the extra load, compared to the simple reinforced concrete. If we talk about the simple reinforced beam, if load is applied on that beam, if it is simply supported beam, then compressive stress is generated at the top of beam, and tensile stress is generated at the bottom of that beam. As we already know that concrete is much better in compression than tension. For design purposes we neglect the tensile strength of the concrete, because it is very low. That's why to make beam sustainable in the tensile stress also, we provide the steel bars in tension zone. Prestress is also the same, but the only difference is that we provide compressive stress in the bottom of beam before application of load, by pulling of steel wires. Let's we take an example of a rubber band. If we stretch it and hold by an apple, then it tries to compress that apple. Same thing is used during making a prestressed concrete. Prestressed concrete is prepared by the two methods. First one is pre-tensioned concrete, and second one is post-tensioning concrete. Never be confused between the prestressed concrete and pre-tensioning concrete, because pre-tensioned is the method to prepare prestressed concrete. In pre-tensioned concrete, firstly steel wires are pulled, which will further act to produce compressive stress. After stretching of the steel wires, concreting is done. When concrete achieve its characteristic strength, then the grip of steel wires are removed. As we remove the wire grip, it tries to compress the concrete, which produce compressive stress in the bottom of beam. In post-tensioning concrete, a beam is casted firstly. During the casting, pipes are provided at the tension zone of the beam, which is at bottom for a simply supported beam. When concrete achieve its characteristic strength, then steel wires are inserted in these holes. Then these wires are stretched using hydraulic machines. After stretching, these wires are hauled up at the end and filled with the concrete. The principle of post-tensioning beam is same as the pre-tensioned beam. If you like this video,
for the pre-stressing reinforcement, high tensile pre-stressing steel is used. In most cases, it is 7-wire strand. Flat lifting slings should be used for transporting the coils. This prevents injuries which might be caused by chains or steel cables. The coil is inserted in a reel for handling. A mark indicates the exit direction. Before laying out the pre-stressing reinforcement, the detensioning cylinders must be prepared on the detensioning end of the bed. Support sleeves are placed on the extended pistons. These transmit the stressing forces until tension is relieved. The operator can guide the strands and control the feed rate personally. On the detensioning end, the strands are anchored behind the transverse anchor plate. The strands are then cut off on the tensioning end. The best way to do this is to use a hydraulic steel cutter. The strands can now also be anchored on the tensioning end. Before the actual pre-stressing, all the strands are tightened. The oil pressure required for this is set on the pump unit. As soon as all the strands are drawn in and tightened, the mold can be closed. The elongation is measured and recorded for checking. When all strands are tensioned, protection devices are applied. The concrete element can now be cast. As the concrete has reached the specified strength, detensioning can take place. To do this, oil is pumped into the detensioning cylinders on the detensioning side. The support sleeves are removed and the drain valves opened. The pistons are pressed back into the cylinders by the stressing force. The strands are cut off with an hydraulic steel cutter or an abrasive cutter. The finished concrete element is lifted out of the mold and taken away.